Now we are looking at some question on the understanding, application, and analysis in chapter 3. Explain why we couldn't determine the empirical formula of copper 2 oxide by heating the copper powder in a crucible. So, copper 2 oxide, we cannot use the crucible to determine its empirical formula, mainly because copper is a less reactive metal. So it cannot react with oxygen by heating it in a crucible. So these are the keywords or key sentences that you need to explain your answer. Next, compare and contrast the empirical formula with the molecular formula using the ethane as the example. So ethane, it has a molecular formula of C₂H₄. So we can simplify it by to get the empirical formula of CH3. So what is the similarity of the empirical formula with the molecular formula? So the type of the elements in both formula are the same. They are carbon and hydrogen. Okay, but the number of atoms for each element are different inside both empirical formula and the molecular formula. Number 9, vinegar is a dilute ethanoic acid with a molecular formula of CH3COOH. Okay, actually we can simplify it becomes C₂H4O2 because we can combine the formula becomes like this. So if we combine it like this, we can easily find the empirical formula for the ethanoic acid. So the A, find the empirical formula, so we can see can simplify the all the atoms in the compound or not. So obviously we can simplify them, so it becomes CH2O. So find the percentage of composition by mass of the carbon in the ethanoic acid. So if we want to find the percentage composition for the carbon, so we can use the formula. That is, use a carbon. There are 2 carbon atoms, so Ar given for the carbon is 12. There are 2 over the total. Okay, there is C₂H4O2. So for carbon is 12, hydrogen is 1, then oxygen is 16. So total up times 100%. So we get 40% for the carbon in the ethanoic acid. (3.6 gram of carbon react with 0.8 gram of the hydrogen to form the compound. So this one is a very common question that we ask in the exam. So A determines the empirical formula of the compound form. So given to you, relative atomic mass for carbon is 12 and hydrogen is 1. So normally I encourage you to draw a table, okay, to solve this question. So first we list out the type of carbon elements. There are 2 carbon and the hydrogen. Okay, so the mass given in a gram would be 3.6 for carbon, so 3.6 gram. Hydrogen will be 0.8 gram. Okay, then as we have the mass, we can find the number of mole by divide with the molar mass. That is, with carbon is 12, hydrogen is 1. So we get mole is 0.3 for carbon and 0.8 for hydrogen. Okay, to find the simplest ratio, we look at both carbon and hydrogen's mole. So we see which one is smaller. So carbon is smaller. So both of the mole here will be divided by the smallest one. So is 0. Divide by 0.3, so you get 1. Then hydrogen we divide by 0.3 as well, so you get 2.67. Okay, so bear in mind you cannot simplify it to 3, so we remain it in the 2.67. So in order to get the whole number ratio, so 2.67 we can times 3, you get 8. So as this one times 3, the hydrogen times 3, carbon also need to be times 3. So it will be 3 and hydrogen is 8. So from here we can find the empirical formula for the compound form would be C₃H8. Okay, so empirical formula is C₃H8. So next, given that the relative molecular mass for the compound is 88 gram, find its molecular formula. So here, molecular formula is 88. Okay, so empirical formula is just now from A is C₃H8. Okay, so the total molecular mass is 88. So we can use a formula. The empirical formula times n, you get 88. So we replace in the relative atomic mass into here to find the n. So we'll get n is equals to 2. So in other words, we can replace the n into the 2 into the empirical formula. So we get molecular formula will be C₃H16 as the molecular formula. Next, hydrogen gas is reacted with 20 grams of hot copper-2 oxide powder to produce a solid copper and water. So write a chemical equation for the reaction and calculate the maximum mass for the solid copper form. So first we look at the chemical equation. So hydrogen gas react with copper-2 oxide powder. So these two are the reactants. So the products form will be copper and the water. So we double check. Copper is 1. Here copper is 1. Okay, it's balanced. Oxygen is 1, 1. Hydrogen is 2, 2. So meaning that this is a balanced chemical equation. So all the reactants and products are correct, 1 mark, and then balancing 1 mark. So all will be 2 marks. Now, B, calculate the maximum of the mass of the solid copper form. In other words, we need to find the mass of the copper form. Okay, so given to you 20 grams of copper-2 oxide. In other words, we can find the number of mole for the copper-2 oxide first. So 20 grams over the molar mass for the copper-2 oxide. So copper is 64, oxygen is 16. So we get 0.25 mole. Okay, 1 mark. Next, we need to do the comparison. So copper-2 oxide is 1 mole. This one is also 1 mole. So in other words, if this is 0.25 mole, copper also 0.25 mole. So the ratio will be the same. So in other words, we can find the mass for this copper. So mass of the copper 0.25 mole times the molar mass for the copper is 64. So we get 16 grams. Another marks for it. So this one also 2 marks.